And I still will post the video of what goes on. So, all right. So we got a car and it's decelerating, which means it has an acceleration opposite motion, right? Deceleration doesn't mean negative; it means opposite. So that's the first thing. Actually, I'm going to put in my y. Have a more interesting color. The acceleration is in the opposite direction of motion. Thus, the speed is getting less. And then they're asking about how does the speed relate to the distance. Yeah, that's what this problem's all about. So, acceleration is the rate the velocity changes, and velocity is the rate the position changes. So there is a more complex relationship between acceleration and distance than just linear. I think that's about all I need for the y. I think. Sure. So how-wise, let's see. I think I'll try typing it. We'll see how that goes. Maybe that'll work. Maybe it won't. I'm looking at I'm thinking right away, because I have acceleration and I have distance are my only two concerns. I don't really care about time. So I'm looking at the relation, come here, too many layers. I'm thinking about this relationship here. So I need to know the initial, let's call it starting velocity. The final velocity. Helps if I can type. And maybe the acceleration or the displacement. The problem gives me the initial velocity, right? Let's see, where is it? Right there. Yep, they give me the initial speed, and I know, so from the initial speed, to get the initial velocity, all I need to do is assign a direction. So what direction do we want to say the car is moving in? Positive, okay. That would mean our our acceleration has to be opposite positive, it's got to be negative. Good, good. So, initial speed, I'm going to call it positive, thus my opposite velocity, opposite acceleration will be negative. I'm also given the final speed. What's our final speed? 0, because it stops, right? It's one of those kind of facts of life again to remember. So, give the final speed of 0 since it stops. Oops, doesn't have double P there. Stops. I'm also given the acceleration. I think it's all in base units too. Let's see. Meters in seconds, meters in seconds, meters in seconds, and they want the answers in meters. Is in base units, so no conversion needed. Things to watch out for. Be very careful that you don't drop the squared terms. For some reason people tend to forget about those when they're doing, like they put in their numbers and then they start using their calculator and they forget that both those velocities are squared. So that will be a common mistake. Yeah, besides that, it's just really plugging the numbers into the correct variables form at this point for each part. Yep. Oh, they only want 2 sig figs. So this should be 100. Alright, so number 15, we've got the crew member sitting on the bathroom scale in calm waters, and then you get a maximum and minimum during. What do scales measure? No, that's a lie. No, it's a lie. Nope, lie. Nope, lie. Normal force. Oh. Because does the crewman's weight or gravitational force or mass change? No, not unless it's like seasick or something like that. But the normal force changes based on the net force on the person. So be careful. That's one of those things you're taught from a young age that the scale is measuring your weight. It's not. It's measuring the normal force that it's applying to you. It doesn't interact with you with your weight, because your weight is between you and the earth, and that's it. So actually we need two force diagrams here. There's our crew member, and there's our crew member, and they're going to have, in both cases, their weight down, and they're going to have a normal force up. But in this case, they're going to be accelerating up, and in this case, they're going to be accelerating down. Notice some key points on my diagram. The forces are actually touching the object. They have to, because they're interactions. Forces require that. The accelerations are not touching the object, because they're not forces. They're just description of how the motion's changing. I think those are the main key points. I've labeled my forces as forces and then what type of force they are. I have not drawn a net force in there, because the net force is the combination of all of the forces, not the individual force. Which way do we want to call positive? Up? Okay. For both? Okay. We'll call up positive for both. So this would be the diagram that should be my y. So I'll throw that into my document as my y. And then for my how, let's see, for the how, I need my general force equation. Let me get in my mouse for this. And let's see, I should probably have a thing that's about that force of gravity, right? Which is right up here. So, these are useful in that this the F sub g helps me by defining my force gravity, but I don't really need it because they tell me the weight, the F sub g, right? Because that's going to be what the scale, the normal force reads in in the what do they call it, in calm waters. So for me, that's 745 newtons. That is the weight of the crew member. In fact, technically, I really should have that third diagram where I don't have any acceleration. And then I can see that relationship. But so the normal force the scale reads, without it accelerating, will always be the weight. So I really don't need this one. I could get rid of that one. I could just throw it away because it won't let me throw it off the page. So I really only need this one here. And I remember that, that summation, that sigma up front, means add up all the forces. So let's take the first case when we're accelerating upwards. Is my normal force positive or negative? Positive. And my gravitational force is negative. So, and remember, this gravitational force I know, for me, is 745 newtons. Since my scale measures normal force when I'm, oh, it doesn't tell me which one is which. At one point it reads 930, the other reads 560. How do I know which one is which? Well, let's see. When I'm accelerating upwards, what direction must my net force be if I accelerate upwards? Must be upwards. The net force must be upwards. So, that might be a nice little note to have over here. Net force upwards. Because my net force and my acceleration are always in the same direction. Can never not be true. So, which direction is my net force when I'm accelerating down? Down. Net force. I wonder if you're making the mistake of seeing F sub n and thinking that means net, not normal. Okay. 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 Well, because I do see a lot of people see n and think, oh, that's net, not normal. So some people write out the whole word there as a subscript if they have that problem. But you don't have that trouble, so ignore it. Remember, this is the net. This is another way to write net force, right? Okay. So, I forgot what we want to know. Acceleration. So, the net force here in this, when we're accelerating upwards, is upwards. What does that mean about the normal force compared to the gravitational force? It's going to be bigger, right? So here, the force normal must be greater than the force gravitational. What about over here, when the total force has to be pointing downwards? Force of gravity must be greater than normal force. So that tells me over here, I've got a normal force of 930. That's greater than 745. So which one is 930? The one when I'm accelerating up, or the one when I'm accelerating down? This one. Because the normal has to be greater than the gravitational. What about the 560? Well, of course, it's Carter. It's the other one. Oh, you know what? I was wrong. We do need this. Because if we look at Newton's second law here, what don't we know? The mass. Oh, we got to find out the mass from here. Right? Because I know F sub G, that's the 745. What planet am I on? Earth. So do I know little g on Earth? 9.81 newtons per kilogram. Yeah. So I know that, and then I can find that m, and that m is the same m. So add up my forces over here to find my net force. Should be a positive number. M I'm going to get once for the whole problem using my definition of weight over here. Then I'll have M, and I can find A. And hopefully I'll get A as positive also when I do it for this side, for the left-hand side. If I get a negative, I mess something up. But then when I do it for the right-hand side, I should get a negative. Where the M comes from? The M I'm going to get from using my definition of gravitational force, my weight. Because I know F sub G, and I know... You good? Okay. Those are the same masses. Because we're talking about the same crew member. That's not a mass, that's my weight. I'm going to use that and this equation to find my mass. So, let's see. Folks, make sure when you put in your answers, remember for part B, it's a downwards acceleration, so it should be negative, because we defined up as positive.